I'm Dr. W.P. Gulmule from Kamlanev Mahavidyalaya, Nagpur. Today we are going to discuss the chapter number 8, transition and inner transition element, and already we have discussed the physical properties and some concept of the transition element, and now today we are going to discuss the extraction of metal from their ores. And as we know that the minerals which occur in the nature are found in the native state or in a combined state, and depending upon the nature and metal line, the metallurgical process are three types. So metallurgy, it is the process of extraction of metal from their ores, and this process of metallurgy are three types. Number one is pyrometallurgy, second is hydrometallurgy, and third is that is electrometallurgy. So these three methods, depending upon the nature of metal line and the ore, we can use out of these three one method of metallurgy. And so metallurgy process consists of different steps, and here we are going to discuss the one example of extraction of iron from their ore, that is hematite. And this method of metallurgy consists of 5 steps. First is the concentration, after that roasting, after that smelting, and then fusion of this, and then after that the refining of the this impure metal, and lastly we get the pure metal. So all these steps we are going to discuss in today's presentation. So today's topic is a transition and inner transition element, and in this today we are going to discuss the contents shown here in this slide, and these are the topics that we are going to discuss are the extraction of metal, what is metallurgy, and three types of metallurgy: pyrometallurgy, hydrometallurgy, electrometallurgy, and different steps involved in the process of extraction, and what is concentration, and after that extraction of iron from hematite or using a blast furnace, and after that different steps of this extraction of hematite, iron from the hematite is a concentration, roasting, smelting, and refining. So different steps are there. So all these steps we are discussing one by one here now. So now first step is the extraction of metals. So in case of extraction of metal, so what do you mean by the extraction of metal? So we can say that when metal is found in the earth crust in elementary form, it is said to be occur in a native state. So we can say that that is the element occur in native state or in a combined state. On the other hand, we can also say that when metal is found in the earth crust in the form of its stable compound, it is also known as known to occur in a combined state. So in free state or in native state or the combined state, it occurs. In combined state, the metals are generally found in the earth crust as a oxide, as carbonate, sulfide, silicate, phosphate, like that. And various compounds of the metals which are found in the earth crust are known as mineral. So we can say that what is mineral? The minerals are those compounds of the element which occur in the nature. So the compound which occur in the nature is known as the minerals. And minerals extracted from the earth crust are not pure, but they are associated with large number of rocky, earthly, or siliceous impurities. The impurities associated with the minerals are also known as matrix or gangue. And so these are about the general what is the procedure of extraction of metal. And also we know that every mineral of the metal cannot be used for its extraction. So in some cases economic factor, while in other availability of the mineral may be the hindrance. So the minerals from which metal can be extracted profitably is known as the ore. So those minerals from which the metal can be extracted profitably, that mineral is known as the ore. And here some examples are given here that earth crust contain aluminium in the form of two well-known mineral, bauxite and china clay. But extraction of aluminium is cheaper and easy from bauxite. Therefore, ore of aluminium is bauxite. Similarly, minerals of copper are copper glans or cuprite or malachite and copper pyrite. But the ore of copper is copper pyrite. Therefore, it can be concluded that all the ores are minerals, but all the minerals are not ore. So important thing is that we can conclude that all the ores are minerals, but all the minerals are not ore. So this is the important point in this case, and here it is shown that so what is mineral, what is ore. So minerals are the compound which occur in the nature, and the ores are those minerals from which metal can be extracted profitably. So this is known as ore. So all minerals are not ore, only those minerals from which metal can be extracted, that mineral is known as the ore. So here some examples have been given, and that is the list of minerals and the ores of some transition metal. So three metals have been shown here in this table: iron, copper and zinc. So minerals are, irons are 1, 2, 3, 4, 5. Hematite is the main mineral, and this is the ore of, out of these 5, all these are the minerals, but this hematite mineral is the mineral from which the iron can be extracted profitably. Therefore hematite is the ore of iron. In the similar way, copper have these three types of: chalcopyrite, chalcocite, cuprite. But chalcopyrite is the ore of this copper. In case of zinc, there are three types of minerals: zinc blende, zincite and also carmine. But zinc blende is the main mineral from which the zinc can be extracted. Therefore these are the ores. So all ores are minerals, but all minerals are not ore, like that. So here we have seen. And also, what is the metallurgy? So metallurgy is a process of extraction of metal from their ore, and the metallurgy are three different types depending upon the we can say that the nature of metal and the ore. The metallurgy are three types. And what is metallurgy? The process of extraction of metal in the free state from its ore is known as metallurgy. So this is the process. Nature of the ore and also properties of different metals are different. Therefore it is possible to have it is not possible to have universal scheme which may be applicable to all the metals. Therefore some common steps are involved in the metallurgical operations, and these steps are crushing and grinding of ore, concentration of the ore, production of metal from concentrated ore, purification of crude metal. So all these are the steps of the metallurgical process. And here, so this is the process, and depending upon the nature of metal and its ore, different methods are used for the extraction of metal. And as we have seen, there are three types of metallurgy. One is a pyrometallurgy, and second is a hydrometallurgy and electrometallurgy. What is pyrometallurgy? So pyrometallurgy is the process in which ore is reduced to metal. So ore is first reduced to metal at high temperature, and for this case we have to use a reducing agent like carbon, hydrogen, aluminium, and is also known as, this process is known as pyrometallurgy. So at high temperature ore is converted or reduced to metal by using carbon, hydrogen or aluminium. And second is the hydrometallurgy. So this process of extraction of metal from aqueous solution of their salt using suitable reducing agent, and this process is known as hydrometallurgy. So hydrometallurgy is a process of extracting the metal from their aqueous solution of their salt using suitable reducing agent. So this is known as hydrometallurgy. And third is the electrometallurgy. And electrometallurgy is a process in which metal is extracted by electrolytic reduction. So in all the cases there is a reduction. So here in case of third electrometallurgy, electrolytic reduction of the molten metallic compound we have to carry out, and this process is known as the electrometallurgy. So metallurgy are three different types depending upon the nature of metal and the ore. And in the next steps, now the different steps involved in the process of extraction. So different steps are concentration, gangue, roasting, smelting and refining. All these are the 5 steps of the concentration, and also gangue, some impurities are there, roasting, smelting and refining. All these are the process in which that process, first process is the refining. As we know, what is refining? So in case of refining, we can what is the first step is the concentration, and in case of concentration of the ore, we can say that it is the process in which the impurities can be removed. before going to further next step. So this is the first step, that is known as concentration. So concentration, we can say that in case of concentration, the ore obtained from the earth crust is associated with the rocky and silicon impurities. It is quite essential to remove these impurities so that they may not cause any interference in the process of extraction. The removal of impurities from the ore is known as concentration of the ore. So this process of concentration, depending upon the nature of the ore and also depend upon the impurities present in the ore. So this is the concentration first step, and in this step we have to remove impurities. So we can say that removal of impurities from this ore is known as the concentration of the ore, and different methods are there to remove the impurities. For example, gravity separation method, froth flotation process, magnetic separation of the impurities, leaching, are the different steps are there to remove the impurities of the compounds. And here now the question is, their second step is the gangue. We can say that in case of this, gangue is the impurity, and second step, that is the in case of this we can say that what is gangue, the sand or mud or other unwanted impurities which remain mixed with the ore and deposit are known as the gangue or impurities. And during the process of concentration, the ore is separated from the gangue material using different methods like washing, hydraulic classification, magnetic separation, froth flotation process. So this we have to, the method can be used, different methods are there for the concentration depending upon the nature of the ore. And now here we are going to see the so these are the different steps, and what is gangue we have given here. So in the next step now, all these other steps, what is roasting is also the smelting, the refining, different steps are there for this case. And here now after this we are going to see the important part of this extraction of metal, and one example is given here, that extraction of iron from the hematite ore using blast furnace. So this is the one process, and here metallurgy process we have to use, and in this case iron metal we have to extract from the ore. The ore of iron is hematite, and using a blast furnace. So again now furnaces are different to maintain different temperature. So different furnaces are there depending upon the ore and nature of the metal. We have to use a reverberatory furnace, blast furnace, muffle furnace, and so many different types of furnaces are there. But for the extraction of iron, blast furnace are there. What is the arrangement in the blast furnace? Also we are going to see how the temperatures are there in different part. That also we are going to see in this part. So in the extraction of iron from hematite ore using a blast furnace. So what is now, iron is extracted from hematite ore by reduction using coke and limestone. And now here carbon in the limestone reduced to the carbon monoxide. So in this case, before going to see that, now see here, this is the Fe2O3, this is the ore, and here along with this iron oxide, what is silica, alumina, phosphate, these are the impurities, or we can say gangue is present in the, so this is the composition of this ore, hematite. So these are the impurities present. So we have to remove all these impurities, and also finally this oxide can be reduced to the metal and we get impure metal, and after refining we get the pure metal iron. So these are the impurities. So we have to remove one by one by different steps the impurities present. And now in this case of extraction of iron, we can say that so iron is extracted from hematite, and here we have to use limestone, and in this case limestone act as a we can say that flux, and it combined with the gangue material to form molten slag. Extraction of iron from hematite ore involves different steps, and different steps involved in the extraction of iron from the hematite, and different steps are, we are going to see the extraction of iron from the hematite. So different it consists of different steps. So different steps are being shown here, and the first step is the concentration, second step is the roasting, and third is the smelting, and zone fusion and refining. So last step last stage is the refining of the metal, and purification of metal. So these are the different steps involved in the extraction of iron. And here first step is the concentration. So what is concentration? Here now we can say that in case of concentration, already we know concentration means it is a process of removal of impurities from the ore. So here as we know that before going to concentration, we have to crush or grind the ore, and for most of the ore obtained from the earth crust in the form of lumps. These lumps have to be converted into powder form, so that chemical changes which have to take place at the later stages may become convenient. The lumps are broken into small pieces in the jaw crusher, or they are further pulverized in a stamp mill or ball mill. So we have to grind it and make it powder first of all, and after making powder we have to go for the concentration can be carried out. As we know, different steps are there, different methods are there for the concentration, and here we can say that the powdered ore is washed in a powerful current of water introduced into the hydraulic classifier, and lighter gangue particles or impurity particles are separated, and the concentrated ore is collected at the bottom. So here the complete procedure is shown here in the figure. See here what are the different extraction. So this is the flow chart is given. This is very important. Different steps are being shown. This is the iron ore. Start from iron ore. Grind it first, make it a powder, then concentrate. So here is shown. After taking iron ore, crushing and grinding the ore. After this, making powder, then do the next step is the concentration. And for concentration, what are the different methods? Magnetic separation, gravity separation, leaching, for flotation process. After concentration, concentration is to remove the impurities. And after concentration, what is the next step? Reduction, also known as the roasting, and to reduce it. So here is the reduction or roasting is the next step. And for the roasting, different steps are there for reduction or roasting. So reduction by coke, reduction by carbon monoxide, reduction by heat, reduction by aluminium, reduction by electrolysis. So for reduction, these are the different steps, any one we can use. After roasting or reduction, then next step is the refining. So after this, here also one more step is there, which is known as the smelting, and after that we have to refine. After refining, we get the pure metal or iron, and for refining, different processes are there. One is a liquefaction, distillation, oxidation, electrolytic refining is also there. So this is the flow chart. See 1, 2, 3 in this way, and lastly start from iron ore, and lastly we get the pure iron. So this is the so in this way. So first step is the here now concentration. First we have to make a powder, after that concentration. So step by step we go for that metallurgy process, and we get finally the pure metal of the iron. So this is the flow chart diagram which clearly shows what are the steps involved in the extraction of iron from hematite ore. So first step is the concentration. And what is concentration? Concentration is the we can say that concentration is the process in which the impurities can be removed. Once the impurity removed means after that concentration, next step is the roasting, also known as. So in case of roasting, now we can say that what is roasting, and we can say that what is the roasting now here. Second step is the roasting. And what do you mean by the roasting? One can ask the question. So we can say that it is the process of heating the ore in the excess supply of air below its melting point. This process is used when oxidation of ore is required. As a result of roasting, different steps are there. That is, the moisture is driven away, means moisture can be removed. Volatile impurities are removed. If there are some volatile impurities, it can also be removed. The impurities like sulfur, phosphorus, arsenic are also removed as their oxide, and the ore undergoes oxidation to form the metal oxide. So in this case here, so this is the process which is known as roasting, and roasting process are carried out in a special type of furnace, and that furnace is known as the, here it is used here, the blast furnace. So this is the roasting process which can be converted to their oxide, and in this case of the in case of iron, the concentrated ore is heated in a current of air, and the sulfur arsenic impurities present in the ore get converted into their oxide and escape as a vapor, so they can be removed. And ferrous oxide in the ore is converted to the ferric oxide here, Fe2O3. So here FeO react with the oxygen and forming Fe2O3. So in this way, this is the roasted of ore is converted to the lumps by sintering. So roasted ore is then converted to lumps. So in the roasted process, this FeO iron oxide is converted to the Fe2O3. So this is the reaction taking place in roasting. And after that, next step is the reduction, also known as reduction, is also known as smelting. And what is now again now question is there, what is smelting? This is the next step. And in case of smelting, also known as here reduction. So in case of reduction, we can say that in this smelting, in this process, the roasted ore is mixed with the suitable quantity of coke or charcoal, which act as a reducing agent, and is heated to high temperature above its melting point. During the reduction, additional reagent is also added to ore to remove the impurities still present in the ore. This additional reagent is known as flux, and flux combined with the impurities to form fusible product. That product is known as slag. So flux plus impurities forming the slag. And in this case of the iron, in this step it is carried out. This step is carried out in a blast furnace. And a steel tower, which is here in blast furnace, is a tall cylindrical steel tower which is lined with the refractory bricks. The height of this blast furnace is 25 meter, and its diameter is varies between 5 to 10 meter. This furnace consists of 3 parts. So this blast furnace is consist of 3 parts, and 3 parts are hearth, wash and stack, which is shown in the diagrammatically in the how these 3 parts are there, 3 compartments are there in the blast furnace. And here this is the diagram of the blast furnace, and here the 3 part, this is the first hearth, here wash, and this is stack. So these are this complete is shown in a 3 part. So this is the first part, this is second, and this is third. And temperature in this furnace increases increases from top to bottom. So temperature is here increases. So here some of the 500 temperature start from 250, and here is around 1200. Here it is up to at the bottom up to 2000 degrees temperature can be maintained. And now in this case, so shown here what are the reactions are taking place at a hearth is shown, and here what are the reaction initially can be, so charge distribution, low temperature, and indirect reductions have been shown, and these are the chemical reactions as have been shown. And here some hot blast air we have to here is a inlet is there, and now some where here we get the pig iron at the last. And so different temperature zones shown in this 3 compartment. And here this is the arrangement, and here is the charging. So carbon monoxide form go up, and also this carbon monoxide react with nitrogen, and what is different types of chemical reactions. So what are the different reaction taking place in the blast furnace, that we are going to see in the next slide. And here chemical reaction that taking place in different zones in the blast furnace, and that 5 are the steps. That one is the zone of combustion, zone of reduction, zone of slag formation, zone of fusion, and last is the refining. So different chemical reactions are there, and first is the zone of combustion. So in case of zone of combustion, we can say that in case of zone of combustion, that is after all these steps, first step is the zone of combustion. And in this case, in this combustion, here see the what we can say that 5 to 10 meter from the bottom, in the blast furnace, this zone is of 10 meter from the bottom, and the hot air blown through the tires react with the coke from the charge to form carbon monoxide. This reaction is shown here, and in this case this is the reaction that carbon react with the oxygen and forming carbon monoxide, and some amount of heat is evolved, and therefore the reaction is known as exothermic, because some amount of heat energy is evolved here, and so this is the exothermic reaction, and therefore temperature of the zone is around 2000 Kelvin. So here temperature is around 2000 Kelvin. Some of the carbon monoxide formed dissociate to form finely divided carbon. So some of the carbon monoxide can undergo dissociation and forming this carbon and oxygen. And hot gases rich in CO rises upward in the blast furnace, and the charge coming down get heated and react with the carbon monoxide, and therefore carbon monoxide act as a fuel, also as a reducing agent. So here this is the first zone where this carbon is converted into carbon monoxide. Carbon monoxide can be dissociated, and sometimes carbon monoxide can act as a fuel, also reducing agent. And so this is the first zone, and this is the zone 10 meter from the bottom of the blast furnace, and temperature here is around 2000 Kelvin. And now second zone is the second zone is the zone of reduction, and this is the 22 to 25 meter near the top, and here temperature, that is the second step, zone of reduction, and here the temperature is around 900 Kelvin, and iron Fe2O3 is reduced to spongy iron by carbon monoxide. So as we know, in first step carbon monoxide is formed. This carbon monoxide act as a reducing agent and react with the Fe2O3 is shown here, and forming the metallic iron. So in this case, this at this temperature, and Fe2O3 reduced to spongy iron by carbon monoxide. So carbon monoxide react with the Fe2O3 and forming this metal Fe, and CO2 gas is get evolved. So this is the impure metal, and some amount of Fe2O3, this some part of the Fe2O3 is also reduced to iron by carbon. So Fe2O3 also react with the carbon and forming this type of metal. So in both here carbon monoxide reduces this to metal, and also some carbon also reduces Fe2O3 to iron, metallic iron. So this is the second zone of reduction. So carbon and carbon monoxide act as a reducing agent, and Fe2O3 reduces to metallic iron. So this is the second zone, and in case of third zone, which is known as zone of slag formation. In case of third step, zone of slag formation. So what is now the slag formation? So we can say that here the gangue present in the ore is converted to the slag, and as we know, this gangue reacts with the impurities and forming the product. That product is known as slag. This slag can be used for making a road foundation, and the temperature of this zone is around 1200 Kelvin. The gangue contains silica, alumina and phosphate. A removal of this gangue is effected by adding limestone in the charge, which act as a flux. Limestone decomposes the calcium oxide, that is quicklime, and forming calcium oxide. So here the reaction is shown. Calcium carbonate, when it is heated, forming calcium oxide and carbon dioxide. Whenever the CO2 carbonate is there, CO2 gas is evolved, and we get the calcium oxide. So calcium oxide combined with gangue to form molten slag of calcium silicate. So it is shown here that CaO react with the silica. So here is the calcium oxide react with the silica, forming CaSiO3, and this calcium oxide also react with alumina and forming this Ca3Al3. So this is the silica, alumina which is present in the ore can be converted to their that is the soluble products, and which can be removed. So in this way this impurity can be removed from this. So in the third zone, in the third case, zone of slag formation. So here is slag is formed, that is the in this case the impurity present react with the flux, and here flux is the limestone, and they form the product, and this product can be removed. So this is taking place in the third stage. And fourth stage is the zone of fusion, and in this fourth stage is the zone of fusion, and in case of this stage, manganese dioxide and calcium phosphate present in the iron ore are reduced to manganese and phosphorus atom. Some of the silica is also reduced to silicon. So in this case, spongy iron coming down, and in the furnace melt absorb impurities like carbon, silicon, manganese, phosphorus, sulfur. This molten iron collect at the bottom in the furnace. The slag, which is lighter, floats on the surface of molten iron. The molten slag and the iron are collected separately, and there is a separate outlet for that. And molten iron is now transferred into molds. These solids blocks are called peaks, and this iron contains about 4% carbon. When pig iron is remelted, run into the mold and cooled, it becomes cast iron. And so first is the pig iron, and then is the cast iron. And the waste gases containing nitrogen, carbon monoxide, carbon dioxide escape through the outlet at the top. These hot gases are used for preheating the blast of air. So this is the 4-step zone of fusion. Here we have to heat, and some impurities like carbon monoxide, CO2 gas, nitrogen gas, they get evolved. And the 5th step, last step, is the refining. And in case of refining, pure iron can be obtained. Now in the last stage we get metal, and in this step of refining, pure iron can be obtained by electrolytic refining of the impure iron, and other methods given in the flow chart. The choice of extraction technique which depends upon the following factors here. So depends upon the nature of ore, availability of and the cost of reducing agent. Generally cheap coke is used. Availability of the hydraulic power, purity of product required, value of byproducts, for example SO2 obtained during the roasting of sulfide ore is vital, important role for manufacture of sulfuric acid. So these are the some factors, so depend upon that we can use the technique. So refining is the last step. In this step, what is now, we have to use the electrolytic refining, and by using this step of electrolytic refining, the pure metal is obtained. So we can say that refining is the important step finally, and purification of this crude metal can be carried out in this electro refining process. And as we know that metal obtained by any of the above methods still contains some impurities, and therefore other metal originally present in the ore, unreduced oxide or sulfide of the metals, residue slag or flux, and non-metals like carbon, silicon, phosphorus are there, and the process of removal of impurities from the crude metal is known as the refining. So this is the refining process. What is the process of removal of impurities from the crude metal is known as refining. The method used for refining of metal depends upon the nature of impurities, and some methods are there, that is liquefaction, pooling, electro-refining. So what is electro-refining? And in case of electro-refining, we can say that this method is based upon phenomenon of electrolysis. The crude metal is made anode, whereas the tin sheet of the pure metal is made cathode. Electrolyte is the solution of some salt of metal. On passing electricity, the metal from anode goes into the solution as ion due to the oxidation. And while the pure metal get deposited at the cathode, due to the reduction of metal ion, the impurities settle down below the anode, and therefore that is also known as anode mud. And so this is the electro refining. So we have to take the solution of electrolyte and 2 electrodes. Crude metal is an anode and the pure metal as a cathode, and mud is settled at the bottom, and oxidation is take place, and metal get deposited on the pure one of the electrode. In this way electrolytic refining can be carried out. That is, in this process we get pure metal from crude metal. So different types of reaction that taking place at different zone of the blast furnace are shown here, and here is at 500 degree temperature there is a loss of moisture from the ore, and at 900 degree Kelvin temperature there is a reduction of ore by carbon monoxide, and here this is the ore react with the carbon monoxide and forming metallic iron. And at 1200 decomposition of lime, so CO2 get evolved and forming CaO, and at 1500 reduction of ore by carbon is taking place, and this ore will undergo reduction with carbon forming metallic impure metal iron, and after that at 2000 Kelvin temperature fusion of iron is taking place, that is the CaO and silica, this can be removed easily, and slag formation is taking place. This alumina react with the calcium oxide, so both these silica alumina present in the it can be removed as a slag, they form the slag and can be removed. So we get the metal oxide ore into their impure metal, and after refining we get the pure metal finally. And as we know that commercial forms of iron are there, and three different types of irons are there, that is known as the iron, three irons are cast iron, wrought iron and steel iron. And here is also differentiation between the three types of iron. One is a cast iron, it is a hard and brittle, and the wrought iron is a very soft, and this is the neither too hard nor too soft. And second point of difference is it contains 4% of carbon. Here second point is it contains less than 0.2% carbon, and steel contains 0.2 to 2% carbon. And the third point of difference is that this cast iron is used for making pipes, manufacturing automotive parts, pots, pan, utensils, whereas wrought iron can be used for making pipes, bars for step bolt and engine belt bolts and rivets, and also steel, it is used for buildings, infrastructure, tools, ships, automobiles, weapon, like that. So this is the difference between these three forms of iron. So here we have seen the different procedure for the extraction of metal, and one example that we have seen the extraction of iron from hematite ore. So different steps are involved. First is the grinding, after that concentration, after that roasting, after that reduction or smelting, after that refining. So different steps are there, and in this case of extraction of iron we use the blast furnace, and three parts are there in this furnace, and maintaining different temperature zone and different reaction taking place at different zone. That what are the different reaction and what is the flow chart for the extraction of iron from hematite ore, that we have discussed, and detail about the different steps we have seen in the extraction of metal, and example that we have seen is the extraction of iron from hematite ore.